Let's study 10th standard ICSE Chemistry Chapter 9 Practical Chemistry Part 2 Action of Heat on Salts and the relevant observations. So first we start with copper 2 carbonate. It's a light green salt, but the color has insufficient evidence to lead us to any conclusion. We'll have to heat it, check the observations, and then deduce which salt it was. Now, first learn this equation. You will notice that there are two observations you could make in the lab. One is that you will be left with a black residue, and also a colorless gas will be released, which will be CO2. But how would you know it's CO2? Well, you'll have to do the test for CO2, which we had studied in part 1. Which is, if the colorless gas is passed through lime water, it turns it milky, but it has no effect on acidified potassium permanganate solution or acidified potassium dichromate solution, thus proving that it is CO2 gas. So if they ask us to write observations, we simply write that it has a black residue and we have a gas, colorless gas, which turns lime water milky, and it has no effect on acidified potassium permanganate solution. That's it. We don't have to mention that copper oxide and carbon dioxide is being released. That's not a part of observation. Even the equation is not required if they just asked the observation. Next, zinc carbonate. When that is heated, we see two observations. A residue is left which is yellow when hot and white when cold. That is zinc oxide. By the way, it's an amphoteric oxide. The other two amphoteric oxides you should be aware of as per your syllabus are lead oxide and aluminium oxide. Lead oxide is buff yellow when hot and yellow when cold, and aluminium oxide is white when hot and white when cold. So that's how you can distinguish between the three amphoteric oxides here. And the second observation is for CO2, same as above. Next, what if zinc nitrate is heated? What is your observation then? Well, here you will have three observations. First of all, a residue is left which is yellow when hot and white when cold, proving that it is a zinc oxide and proving that the salt is a zinc salt. Secondly, you will see a reddish-brown gas released, which turns acidified ferrous sulfate from green to brown. That proves that the gas is nitrogen dioxide, and that proves that the salt was a nitrate. So that's how we came to a conclusion that the salt is indeed zinc nitrate. Now there is one more observation which we can make is if we insert a glowing splinter in the gas. Although we can't see the colorless oxygen gas, we will only see the reddish-brown gas, but we are pretty sure that oxygen is also released. So we will see that the glowing splinter is rekindled, proving that oxygen is also released. Although in exam they will ask for maximum 2 observations, so these 2 should suffice. Now there is one more observation that you may initially notice. You see zinc nitrate, which is provided in the lab, may be hydrated zinc nitrate. That is, it will have some water of crystallization with it, which is not shown in this equation. But if there is, then the water will evaporate initially, and the crystalline substance will become amorphous, and the water vapor released will turn cobalt chloride paper from blue to pink. So that is an additional observation you will get even before getting these 2 observations. Again, we won't use it in our tests, but it's good to know information. So totally, I have discussed 4 observations for this chemical reaction. Next, what if the salt given to you is copper nitrate? Then what is the observation? What are the observations you will notice? Well, a black residue is released. Black residue. Well, in our syllabus, we just have 2 things with black residue: copper oxide and manganese dioxide. So that limits the number of options. So black residue should be copper oxide out here. But how can we distinguish between copper oxide and manganese dioxide? That we'll study later. We also see a reddish-brown gas which turns acidified green ferrous sulfate solution brown. Or, you can go for another test of NO2 like it turns potassium iodide paper brown. So this proves that the salt is copper nitrate. And of course, the test of oxygen and water vapor also go hand in hand out here too. And then my favorite, lead nitrate. When it is heated, you will see a residue which is buff yellow when hot and yellow when cold, which is also called litharge, lead oxide, lead monoxide. Give the test for nitrogen dioxide and oxygen as well. And there is an additional test here. There is a decrepitation sound or a crackling sound, which is only heard for the thermal decomposition of lead nitrate. There is no water vapor given out here because it is not hydrated at all. By the way, the litharge will fuse with the glass on strong heating. That's just some extra knowledge. Now, let's understand how to distinguish between copper oxide and manganese dioxide, because both are black. Step 1. Take both the black substances in 2 different test tubes and heat them with conc HCl. Look at the reactions. They react differently. Here, no chlorine gas is released. There is no greenish yellow gas is released. Whereas here there is a greenish yellow gas released. So that is hint number 1, that this test tube has manganese dioxide. But let's be doubly sure. Let's go ahead. Now whatever solution is left behind, that is copper chloride solution and manganese chloride solution, filter it. Here the filtrate is bluish in color, which is copper chloride. And here the filtrate is brownish in color. You see they are insoluble, by the way. So they'll be filtered out. And the color of this residue on the filter paper, called the filtrate, confirms that indeed this one is manganese dioxide, whereas this is copper oxide. There is some extra step if you want to be triply sure, but it's not very important. You can learn it for general knowledge. Now let's understand how we can distinguish between acidic and alkaline solution. Yes, the indicators will tell us which one is acidic and which one is alkaline by changing their color. But let's go for a chemical test. In exam, we should always write a chemical test. Now there are 2 tests. One is positive for acids and the other is positive for alkaline. So let's study this one first. If you add sodium carbonate and heat it, then here in this case carbon dioxide is released. Remember, whenever an acid reacts with a carbonate, CO2 is released. But how will you know it's CO2 is released? In the observation, we can't just see CO2 written on the gas molecules coming out of the test tube, right? And so we can't write that. We would rather say that a colorless gas is released which turns lime water milky and has no effect on acidified potassium dichromate solution. Whereas here we see no such observation, hence it is an alkaline solution. One more thing we can do is we can add ammonium chloride and heat. So any one test is sufficient. If we add ammonium chloride and heat, again, acidic solution will have no effect on this. That is, we won't see any observation. But here, if you remember, ammonium chloride does react with alkaline solution to give you ammonia gas. But how will you know that ammonia gas is being evolved? Well, you will see a colorless gas being released which gives you dense white fumes when a glass rod dipped in conch HCl is brought near it. That is a test for ammonia gas. So now you know why knowledge of the tests for gases was crucial to study ahead. Now talking about acids, we should know how they impact the various kinds of salts here and the relevant tests. Any carbonate or bicarbonate will react with a dilute acid to give you salt and carbon dioxide, and we know how to test for CO2. If you react the acid with sulfite, it will give you sulfur dioxide, and if you react with sulfide, it will give you hydrogen sulfide gas. These are the typical properties of any dilute acid. But how will you identify SO2 or H2S gas? Well, we've learned in part 1 the tests for gases. SO2, it turns lime water milky and changes the color of acidified potassium permanganate from pink to clear colorless, or acidified potassium dichromate from orange to clear green. And hydrogen sulfide will go for the easy test. It turns moist lead acid and paper silvery black. Now, finally, let's talk about the amphoteric oxides and amphoteric metals. They're amphoteric because they react with acids, of course, to give you hydrogen gas. So we have hydrogen gas released by aluminium, zinc, and lead, even with an alkali. That's why they're called amphoteric. Now, their oxides would react with acids to give you salt and water, but here we can see that with hot and conch alkalis also they can give salt and water. Hydrogen gas can, of course, be identified by their pop sound when a burning splint is brought near it.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.